This is 5.3, Solving with Elimination, Day 3. So this is Day 3 of Solving Systems by Elimination. Today we're going to be looking at when we have equations where both equations need to be multiplied by a constant. So far we've worked with ones that already had opposites and systems where we only had to multiply one equation by a constant. Today's examples, both of them will need to be transformed by multiplying by a constant. So in our first example, we have negative 2x plus 3y equals 7, and 5x plus 8y equals negative 2. My terms are negative 2x, positive 3y, and 7, positive 5x, positive 8y, and negative 2. When I look at my x terms, I have a negative 2 and a 5, and my y terms, I have a 3y and an 8y. If you notice, there's no way I can just transform this negative 2 into a negative 5, nor can I change the 3 into an 8 through simple multiplication. So what you need to do is decide, first of all, which terms you want to work with, the y terms or the x terms, and then you need to find the least common multiple of the two terms. And when you're trying to find the least common multiple, you're going to temporarily ignore the signs that are opposites. For example, if I have a negative 2x and a 5x, and these are the ones I'm going to want to work with because the signs are already opposites, I'm going to ignore this negative 2 when I'm looking for my least common multiple. So remember, with the least common multiple, you're thinking about all the multiples of the number. So the multiples over 2 are 2, 4, 6, 8, 10, etc. The multiples of 5 are 5, 10, 15, etc. So what you're looking for are the ones that you have in common. Got a 10 and a 10. So I want to convert both of my x terms to have a coefficient of 10. Let me move this stuff out of the way here. And we're going to convert the first equation so that it has a coefficient of, instead of negative 2, a negative 10. So I'm going to rewrite my equation, negative 2x plus 3y equals 7. And I'm going to multiply the entire equation times 5, because my goal is to get to a negative 10. So I'm going to distribute the 5. 5 times negative 2x is negative 10x. 5 times 3y is 15y. And 5 times 7 is 35. And I'm going to do the same thing to my second equation. I have 5x plus 8y equals negative 2. And I'm going to multiply the entire equation times 2. So 2 times 5x is 10x. 2 times 8y is 16y. And 2 times negative 2 is negative 4. So now in my two equations, my two new equations, I have negative 10x plus 15y equals 35, and 10x plus 16y equals negative 4. My x terms are now opposites, so I'm going to rewrite these and use elimination to solve. So here are my two new equations. I'm going to combine negative 10x and 10x, which cancels out. 15y plus 16y equals 31y. 35 minus 4 equals 31, so I get 31y equals 31. Divide both sides by 31, and I get y equals 1. Then from there, I'm going to find my x term using substitution. When you're substituting, you can use any of the equations. I'm going to use one of the ones we had above. 5x plus 8y equals negative 2. I'm going to substitute 1 in for y. So I get 5x plus 8 times 1 equals negative 2. 5x plus 8, because 8 times 1 is 8, equals negative 2. Subtract 8 from the left, subtract 8 from the right. I get 5x equals negative 10. Divide both sides by 5. And I get x equals negative 2. So my ordered pair for this system is negative 2 1.